Welcome back to another chemistry mole video. Here we're going to be looking at the reactions of amino acids. So the first reaction we'll look at will be an amino acid with an alcohol. We'll then look at the reaction of an amino acid with an acyl chloride. And then we're going to look at amino acids when we've got more than one amine or more than one carboxylic acid group attached. So in our first reaction, let's have a look at the reaction of a general amino acid. So we're not defining what the R group is here. We're going to be reacting this one here with methanol. So if we react these two together, the key thing to note here that this is an esterification reaction. So you've got the OH group of the alcohol and you've got the carboxylic acid group of the amino acid that's going to react together. So for that reaction, we're going to need an acid catalyst such as sulfuric or phosphoric acid for this reaction. So I'll draw the product of the reaction just that you're aware of everything that's going on. So if we look here, because we've got an amine group on the amino acid and we're using an acid catalyst in this reaction, we're going to have a reaction between the two. So we're going to have a proton transfer over to the amine group. So it's important that you recognize that at the end, this will be an NH3 plus group attached here. So rest of the molecule, carbon with the R group, and then carbon double bond oxygen. This part is left over from the amino acid. Then attached here, here's our ester. So it's the oxygen here from the alcohol, and then the CH3 group from methanol is attached. So this is an ester. We've got to use an acid catalyst for this reaction. And then finally, because we lose the OH group here, this is going to allow us to produce water. So we've got the OH group from the amino acid, and then we've got this leftover hydrogen here. So we get water produced, H2O, in that reaction. So it's just a general esterification reaction. Our second example is reactions of acyl chlorides. So again, just not defining what the R group is, we're only really focusing in on the reacting groups. So this time we're going to be interested here in the amine group's reaction with an acyl chloride. So react the two together. This time no catalyst is required for the reaction due to the really high reactivity of the ethanol chloride. We're going to then produce an amide from this reaction. So we've got the CH3 here on the ethanol chloride, carbon then with double bond oxygen here, so that's this section. We then produce an amide or a peptide bond here, so that's our peptide bond or an amide linkage. Carbon in the center with the R group. Here's the hydrogen, carbon, double bond oxygen, and the OH group for the carboxylic acid, which does not react this time. And then finally, we've got to account for this lost hydrogen, this chlorine. So we're going to produce hydrogen chloride in our reaction here. So focus in on the functional group. That's the most important thing. Isolate the functional group and just think about how that would react even if it was on its own. So you could ignore the rest of the molecule and just think, how would an amine group react, or how would the carboxylic acid group react? In the second half of this video, we're going to have a look at the reactions of amino acids when we've got more than one carboxylic acid or more than one amine group attached. So in the first example, aspartic acid, so we're now defining what the R group is at the top. We've got two carboxylic acid groups. So we need to think about what would happen if we tried to react this with methanol. So you've just got to be aware and able to spot that in the reaction, you're going to produce two ester groups here. So we're going to have two methanols reacting in this. So both of these groups are going to react. That means that our carboxylic acid at the end, our resulting product involves the reaction of both carboxylic acid groups. So amine group here remains. That will become NH3 plus because it's reacting with the acid catalyst in there. We've then got carbon here in the center. We've still got our CH2 group, but we've now produced an ester at the top from the methanol. We're also going to produce another ester group here off of this carboxylic acid as well. So we also form this ester twice. So we've got two methanols. That also means because we've done this twice, we've also got to produce two water molecules out of this reaction. The other reaction to think about is what would happen if we had two amine groups and we were to try and react this with an acyl chloride. Again, we'll use ethanol chloride. So this time we've got two amine groups and one carboxylic acid group. React the two together. You're then going to produce the amide at the end here, and you're also going to produce an amide on this group here. So if we draw that one out, we've got CH3 here, carbon, double bond oxygen, and then to produce the amide linkage or peptide bond, we've got the nitrogen here, we've got the carbon, hydrogen, and the rest of the carboxylic acid group here on the end. That's this section. And then we'll also have the amide produced at the top, where this nitrogen also reacts to produce the amide again at the top. Obviously, if it's happening twice, make sure it's balanced. You need two ethanol chlorides to make this reaction happen. And then because we're losing two hydrogens here, two chlorines here, we're also producing two hydrogen chlorides in the reaction as well. Thank you very much for watching. Please make sure to like, subscribe and share the videos as well.